Hello friends, next type of questions. Question number 26. Construct a minimal DFA that accept set of all strings over 0, 1, which when interpreted as binary number is divisible by 2. Clear? What are the input symbol for this? 0, 1. We can write this question as congruent 0 mod 2. How many number of states in this type of question? Same as number of remainders. By default in this question we include epsilon is accepted. What is the language? 0 is accepted. Epsilon is accepted. 0, 0 is accepted. 0, 0 is accepted. 1, 0. What is the 1, 0? It is 2. 2 divided by 2, remainder is 0, and so on. Number of states, remainder 0 possible and remainder 1 possible. This is the final state. Any number of zeros is accepted because 0, the decimal number of 0 is 0. 0 divided by 2, remainder 0. When we seeing a 1 in this state, it goes to the remainder 1. If the binary number is 1, convert into decimal 1. 1 divided by 2, remainder is 1. Now come to this state. After 1, we seeing a 1. What is this number? 2. 2 divided by 2, remainder 0. When we seeing a 0 in this state, it goes into this state. After seeing a 1, we can see 1. What is the number? Decimal number 3. 3 divided by 2, remainder 1. This is the DFA for this language. Make the transition table for this. 0, 1. How many number of states? Same as number of remainders. This is the final state. Q0 on 0, Q0, Q0 on 1, Q1, this is the Q1, this is the Q0. Q1 on 0, Q0, Q1 on 1, Q1. This is the transition table for this DFA. Please see carefully. We can make another question from this. Congruent 1 mod 2. When we divide a binary string by 2, the remainder is 1. Remainder is 1. What is the difference between this DFA and this DFA? This is the remainder 0. This is the remainder 1. This is the final state. In this DFA, epsilon is not considered in the language. On seeing a 0, same state. On seeing a 1 in this state, goes into the final state 1. The binary number 1 is converted into the decimal is 1. 1 divided by 2, remainder 1. When we see 0 after 1, the decimal number is 2. 2 divided by 2, remainder 0. It goes into this state. When we see 1 after 1, this is 3. 3 divided by 2, remainder is 1. This is the DFA for this question. Clear? Check. Please check this question. Okay. Next question. Question number 27. Construct a minimal DFA that accept set of all strings over 0, 1, which when interpreted as binary number is divisible by 3. Please see the this question. In this question, epsilon is considered in the language. If we cannot consider the epsilon, then another state is one more state is added. This is not initial state. This one is the initial state. If we not consider epsilon, then this is another state. The transition for this state is 0 in this and 1 for this. Clear? Try to do this question. There is also 3 questions are possible. There are also 3 questions are possible. 0 mod 3, 1 mod 3, congruent to mod 3. These 3 questions are possible. Try to do this. How many number of states? Number of reminders. This is 0 reminder, this is 1 reminder, this is 2 reminder. When we do this, this is the final state. When we do this, this one is final. When we do this, this is the final state. On seeing a 0, on this state, this is Q0, Q1, Q2. Clear? When we seeing 1 on Q0, this is the binary number, convert into a decimal. Decimal is 1, divide by 3, remainder is 1. After seeing 1, another 1 is come on Q1. What is the decimal number? 3. 3 divided by 3, remainder 0. After seeing a 1, we can see 0 on this state. What is this number? This is 2. 2 divided by 3, remainder 2. 0. 1, 0, we can see 0. What is this number? This is 4. 4 divided by 3, remainder 1. 0 is here. 1, 0, 1. This is 5. 5 divided by 2. 5 divided by 3, remainder 2. Then 1 is here. This is for this question. See the transition table for this question. Zero, 1. How many number of states? Q0, Q1, Q2. This is the initial and this is also final. Q0, Q1, Q2, Q0, Q1, Q2. This is the transition table for this DFA. Question number 2. This state is make us final state. Q0, Q1, Q2. Same transitions. Clear? Next, for this state is final state. Q0 on 1, on 0, Q0 on 1, Q1, Q1 on 0, Q2, Q1 on 1, Q0, Q2 on 1, Q2, Q2 on 0, Q1. Clear? See the transition table carefully. Clear? Same question is repeated for divisible by 4. Divisible by 4. Binary number is divisible by 4. Binary number is divisible by 4. Binary number is divisible by 4. Next. Divisible by 4. There are 3 questions possible. 0 mod 4, 1 mod 4, 2 mod 4, 3 mod 4. Okay. Please see the short trick. See the short trick for this type of question. Only this type of questions. Only this type of questions. Input is binary, ternary, any number of inputs. Number of inputs 0 and 1. How many number of states are possible? Same as number of reminders. How many number of reminders? 4. 0, 1, 2, 3. How many number of states? 4. Q0, Q1, Q2, Q3. This is the initial state. Divisible by 4. It means remainder is 0. This one is final. Write the number of states. Q0, Q1, Q2, Q3. Again repeat. Q0, Q1, Q2, Q3. Clear? Clear? This is the DFA for divisible by 4. But this is not minimal. This is not minimal. Why it is not minimal? Please see these two transitions are same. These are not same. Why? These are not same. Because this is the final state and this one is non-final state. We cannot merge final and non-final. We can merge only final states and non-final states. So we can merge these two states. What is the minimal DFA for this? 0, 1. After some time, I will give you another short trick for this. Another short trick for this. This state is as it is because this is the final state. Q0 and Q1. Merge these two states. We can write Q13. Q13. This is also 13. Q2, Q13. Because we merge Q1 and Q3. Q1 and Q3. The new name is Q13. Q2, Q0, Q13. This is the final DFA. This is the final minimal DFA. This is also a DFA but not minimal. This is the minimal DFA. In the GATE examination asked how many number of states in the minimal DFA? 3 states. 3 states. Please look at this concept. Clear? See the another question. What is the question number for this? Another question number 27. Find the number of states in minimal DFA. क्वेश्चन नंबर 28 लिख देते हैं इसको. Find the number of states in minimal DFA that accept all binary numbers whose integer is equivalent all the binary numbers which when set of all binary numbers which when interpreted as binary number is divisible by first question. 5 second question. congruent to mod 8. Third question, congruent 1 mod 10. Fourth question, congruent 3 mod 12. Fifth question, congruent 4 mod 16. 4 mod 16. Find the number of states. Another question, 1 mod 7. Try to do this fast. Try to do this fast. First question, divisible by 5. How many number of remainders are possible? 5. 0, 1, 2, 3, 4. Number of states 5. 0, 1. Q0, Q1, Q2, Q3, Q4. Which one is final state? This one. Write the number of states Q0, Q1, Q2, Q3, Q4. Again start Q0, Q1, Q2, Q3, Q4. Where the number of states is end, start with initial state. There are any similar transitions? No. This one is Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4. There is no same transitions. Then it means this is the minimal DFA for this language. Then how many number of states? 5. How many number of states? 5. Second question. Try to do the second question. Do fast. Okay. Divide by 8. How many remainders are possible? 8. 0, 1, 2, 3, 4, 5, 6, 7. Number of states are possible? 8. 0, 1. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. Write down the number of states Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. Again start Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. Which one is final state? Reminder 2. This one is the final state. This one is the final state. Check. There is any state have same transitions? Yes. There are a lot of same transitions. Which one? This one and this one. Q0 and Q4 are same. Q0 equivalent to Q4. We can write this as a Q0, Q4. Okay. And again, Q1 and Q5 are same. Q1 and Q5 are equivalent. This is right as Q1, 5. This is the final state and this one is non-final state. We cannot merge these two states. Also, this is known as minimization of DFA. There is a separate table, separate topic for minimization of DFA. And 3 and 7 are same. 3 and 7 are same. Q3 equivalent to Q7. This is known as Q37. Now, merge these states 0, 1, Q0 as Q04. This is the initial state. Q04, 1 as Q15, Q15, Q2, we cannot merge Q2, Q2, Q37, this is Q2, Q4, Q5, Q4 it is written as Q04, Q5 it is written as Q15, Q15. Okay. Now Q3 written as Q37, Q6, Q37. Which one is next state? Q4 already written, Q5 is already written, Q6, Q6, Q04, Q15. Okay. Q7 is also written, Q37. Again check there is any similar transition in any state. Yes, these are the similar. Merge these two states. Merge these two states. Merge these two states. Merge these two states. 0, 1, Q046. New name is Q046. Q046. Q15. Q15. Q2. Q37. Q2. This is the final state. Q046. Q15. Q37. Q046. Q37. This is the final minimal DFA. This is the final minimal DFA. How many number of states? 4. See the pattern. When we divide a binary string by the odd number, then number of states are same. See. When we divide 5, minimal number of states 5. When we divide 8, number of states are 4. Now check for this 10. Check for 10. When we divide a binary string by 10, the number of remainders are possible 10, 0 to 9, 0 to 9. Then how many number of states? 10. 0, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the initial state. One more 10. Which one is final? This one is the final state. Write down the number of states. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9. Now check. which are same. Q0 and Q5 are same. Q2 and Q7 are same. Q2 and Q7 are same. Q7. Okay. Q3 and Q8 are same. Q3 and Q8 are same. Q4 and Q9 are same. Q4 and Q9. Q4 and Q9. Clear? These are them. The new state is Q05, Q27, Q38, Q49. Clear? Now, write down this. I will tell you shortcut. This is the actual method. I will tell you shortcut within a few minutes. Within a few minutes. Zero, 1, Q0 as Q05, Q05, Q1 is not merging. Next Q1, this is the final state. We cannot merge non-final final. We can merge only final final or non-final non-final. Q27, Q38, Q27, Q49, Q05. Okay. Next is Q38, Q6 is not merge. Q6, Q27. Q4 is merged with 9, Q49. Q8 is merged with 3, Q38. Q49. Okay, this one. Q5 is already written. Q6, Q6, Q27, Q27, Q38, Q38. Okay. Again, there is any similarity? No, there is no merging state. This one 05, 1, 27, 38, 49, 05, 6, 27, 38, 49, 27, 38. These are same, but this is final, this is non-final. That's why we cannot merge Q1 and Q6. Then number of states is 6. Number of states is 6. See the short trick, please. Note. When we divide, this short trick works only when we divide a binary number. Only for binary numbers. Only for binary numbers. This one, this is actual method. This short trick works only for binary numbers. When X mod M, then only for binary numbers, then number of states in minimal DFA. First, if m is odd, then minimum number of states equal to m. Equal to m. Okay. If m is even, then there is two possibility. If m is even, then there is two possibility. First one is m not equal to 2 की power. If we cannot represent m into power of 2's, first possibility, if m is not represent in power of 2, then number of states divide by m until remainder is odd. Until the remainder is odd. For example, please listen carefully. Divide m until remainder is odd. For example, 10 divided by 2, remainder is 5. Then number of states 5 plus 1, 6. See, there are number of states are 6. Clear? If m is represent in power of 2's, if m is represent in power of 2, m equal to 2 की power x, then number of states in minimal DFA equal to x plus 1. See, when we divide the 8, we can represent 8 as 2 की power 3. This is the x. Number of states 3 plus 1. Number of states in minimal DFA 3 plus 1, 4. See this? When we divide binary string by 8, the number of states is 4. Clear? In minimal DFA. Clear? Okay. Do another questions. What is the question? Congruent binary number 3 mod 12. 12 is even? Yes or no? Yes, 12 is even. Divide by 2. What is remainder? 6. Again divide by 2. What is the remainder? 3. This is odd. 3 plus 1 for this. Number of states 5. For this, minimum number of states is 5. Clear? What is the next question? Congruent 4 mod 16. Okay. 16 we can represent 2 की power 4. This is the x. 4 plus 1. Minimal number of states 5 for this question. Clear? Please check. Clear? another questions. Wait. No. Okay. Another examples. Same question. Set of all strings which when interpreted as binary number is divisible by. First question. Congruent 3 mod 9. 3 mod 9. Okay. Next. Congruent 5 mod 12. Third. Congruent 4 mod 20. Fourth question. 5 mod 36. Fifth question. 3 mod 64. Sixth question. 10 mod 128. Next question. 1 mod 198. Try to do this. Find the minimum number of states in minimal DFA. Okay. This is odd. Then minimum number of states 9. This is even, but we cannot represent in power of 2. So divide by 2, 6. Divide by 2, 3. Number of states 3 plus 1 for this plus 1 for this equal to 5. Minimum number of states 5. For this 20 divided by 2, 10. 10 divided by 2, 5. 5 plus 1 plus 1, 7. Minimum number of states 7. For 36, we cannot represent in power of 2's. 18. 18 divided by 2, 9. 9 plus 1 plus 1, 11. Minimum number of states 11. Clear? Next, 64. We can represent 64 as 2 to the power 8. Sorry, 2 to the power 6. Number of states, minimum number of states 6 plus 1, 7. 128. 128 2 to the power 7. Minimum number of states 7 plus 1, 8. Within a seconds, we can give the answer. 198 divide by 2. 99 plus 1, 100. 100. Minimal number of states are 100. Clear? Clear? नेक्स्ट क्वेश्चन क्लियर है? ओके, नेक्स्ट क्वेश्चन. Change the base. Change the base. Instead of binary, we use ternary input symbols. Ternary input symbols. Question number 29. Construct minimal DFA that accept all the string of base 3 whose integer equivalent is divisible by 3. Okay, divisible by 3. So what is the input symbol? 0 1 2. Write the input symbol 0 1 2. How many number of remainders are possible? 3. 0 1 2. Number of states 3. 0 1 2. Which one is final? This one. Write down Q0 Q1 Q2. Q0 Q1 Q2. Q0 Q1 Q2. These states are same. These two states are same. Merge these two states. Merge these two states. So after merging, how many minimum number of states? 2. How many minimum number of states? 2. Which one? 0 1 2. Q1 and Q2 are merged. Q1 and Q2 are merged. These are not say merged because this is the final state and this is the non-final state. Are you getting my point? Are you getting my point? Okay, next question. Same question. Divisible by 4. Divisible by 4. Divisible by 4. Divisible by 4. How many remainders are possible? 4. 0 1 2 3. Number of states 4. Possible number of states 4. What is the input? 0 1 2. Because we use base 3 number. Write down the number of states Q0 Q1 Q2 and Q3. Which one is final? This one is final. Q0 Q1 Q2 Q3. Q0 Q1 Q2 Q3. Q0 Q1 Q2 Q3. Clear? There are no same states. This one is 3 2 1. There is no same transition. Then the final number of states in minimal DFA 4. There are no states which can be merged. This is the minimal DFA. Clear? Please check this question. Clear? Okay. Next question. What is the question number? Question number 30. Question number 30. Find the number of states in minimal DFA that accept all the number of base 4 whose integer equivalent is first question divisible by divisible by 4. Second question congruent 1 mod 6. When we divide 6, the remainder is 1. Okay. There is no short trick, same as binary strings. When we use the base 2, first question. What are the input symbols? 0, 1, 2, 3 in base 4. When we divide 4, how many number of remainders are possible? 0, 1, 2, 3. 4 remainders are possible. 0, 1, 2, 3. This is initial. Which one is final? This is final. Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. We can merge these 3 states. These 3 states are considered as 1 states. Then how many number of states in minimal DFA? 2. These are merged. These 3 states are merged. Clear? We cannot merge with Q0 with these 3 states because Q0 is final states and Q1, Q2, Q3 are non-final states. Clear? Next, 1 mod 6. Input symbol 0, 1, 2, 3. How many number of remainders are possible? 6. Then we have on 6 states, possible 6 states. Q0, Q1, Q2, Q3, Q4, Q5. This is the initial and this one is the final. 1 mod 6. Write down the states Q0, Q1, Q2, Q3, Q4, Q5, Q0, Q1, Q2, Q3, Q4, Q5, Q0, Q1, Q2, Q3, Q4, Q5, Q0, Q1, Q2, Q3, Q4, Q5. Check. We can merge any state. Yes, we can merge these two states. Yes, we can merge these two states. After merging, how many number of states? When we merge Q0 and Q3, Q03, Q2 and Q4, Q03, Q1, Q2 and Q5, Q2 and Q5 को merge कर रहा हूँ मैं. Q3 not merging. Sorry, Q3 is merged with 0. With 0. This is 03. This is 03. Next is Q1. Q1 is Q4. Q4 is merged with any state? No. Q5 merged with Q2. Q25. Q03. Q1. Okay. Next Q2. Q2 merged with Q5. Q25, 03, Q4, Q25. Okay. Next state is this is merged with this Q4. Q4, Q4, Q5, Q25, Q03, Q1. Any other states we can merge? No. Then the minimum number of states are 4. Clear? Clear?